Hi everyone. So today let us continue what we have been discussing in the previous videos. So let us start with the yes. We were discussing linear regressions, and this is a use case or a type of supervised learning, regression and classification. So in the linear regression, there is something called hyperparameters. So hyperparameter is how you train a model. These there are three main types of common types of parameter hyperparameters: learning rate, batch size, and epoch. So how it is different from the parameters is parameters are variables like weight and bias, and they are part of the model. They are the part of the model itself. But hyperparameters is the part of learning. How when you train a model, so that is part of learning or a training. When you control the model, train a model, so these are the so that is what is called a hyperparameter. And some of the common types are learning rate, batch size, epoch. Now, what is learning rate? Learning rate is a number which influences how quickly a model converges. By converges, it means that you see this is the loss, this is the number of iterations. How many times model trains over a particular data set. So the faster the learning rate, the faster the convergence will be. So if you keep the learning rate very high, I will show you a chart. Yes. So this is an interactive gradient descent explorer. Yes. So if you see, we can control the learning rate here. This is the data integration line label, and that is a feature that we talked about in the previous video. Label is the output part, and feature is the input part. And this is the landscape, loss landscape. I mean mean square error that we talked about. It will also show a convergence graph. And how it works is that first it calculates loss. When we set a particular learning rate, let's say I set up learning rate at 0.003, and now I can start the run. Now see, it adjusts the weight and the bias based on the learning rate. Now number of iterations it takes, and this is the automatic loss calculation is there, and there will be a convergence on this continuous change. So this is a learning rate. And the second type of hyperparameter is a batch size. In the batch size, it describes that what is the number of test example from the data set that it takes to train a particular type. So batch size is a so see, if we take too large learning rate, so this is the loss graph comes. So batch size is the number of examples that model processes before updating its weight and bias. So each update for its weight and bias. So what is the number of example that model takes? That is the batch size. Now there are the three different, I think, common techniques: SGD, uh, mini batch, SGT. Now, and third one is the epoch. Epoch means that model has processed every example during training. An epoch means that the model has processed every example in the training set once. So if there are 100 examples in a training set, for example, given a training set with 1000 examples and a mini batch size of 100 examples, it will take model 10 iterations to complete one epoch. You divide 1000 by 100, so it comes out 10 to complete one epoch. So how we calculate one epoch? And here it is a graphical example. This is a batch, full batch, where we there are 1000 examples. Now this is a single batch, or we make 100, a small batch, or called a mini batch. And this is one epoch: 10, 1, 2, 3, 4, 5, 6. We in each of the uh, this is a decomposed version. When you complete a full training of uh, one completion of full training of data set is called one epoch. And now here is a table which explains that there are three different types: full batch SGD and mini batch SGD. what does full batch means, and when it wait and bias update occurs. So full batch, all the examples, the like here you see in the full batch, if you see, let pause it. So in the full batch, it means that you see there is a called iterations. What does iteration means? That uh, the update of weight and bias. So in each of the iterations, if we take the full batch, so in the full batch, weight and bias are updated after all the test example have been trained. After that, weight and bias are updated in the full batch. But in the SGD case, each example, after each test example, weight and bias are updated. And this gradient descent, this is all gradient descent type of a learning for updating the uh, weighted bias. So gradient descent basically means that you lower the downhill, you lower the values to find the minimum loss. So you see, you lower the values of the, so we were, yes, here. Now what does mini batch SGD means? It is between the full batch and SGD, that you take example of 10 test examples, and again you update the weighted bias. Then again after you take 10 examples, you train them and see what is the loss, and then again you update the weighted bias. And it is repeated until the convergence. So convergence means basically a minimum or the lowest loss based on the weighted bias that we have. Okay, anything else that I want to discuss? Okay, in the next we are to uh, implement this in a program where we will take a particular data set and explore the or visualize the data set. Here in example Google Colab, they have taken a data set for a Chicago taxi, I think, fare, and we will predict what would the taxi fare for a particular month. So we will install particular libraries, we will load the data set, take a particular one features and train the model and see that what is the predictive power or the relation between that feature and the label. We will build some correlation matrix. One means perfect correlation, minus means perfect negative correlation, zero means no correlation. So based on one feature, we will see what is the output or the label for that particular model. So I've not implemented or done this, but after this linear regression hyperparameter, you see there is a gradient descent interactive exercise. Yes, let me show you this. So here the three hyperparameters that I just talked about, we can set here. Let's say I select the learning rate to be, let's say, let me keep it maximum and minimum. Let's say I will start the learning now. You see. So in the maximum learning rate, if you increase the learning rate to the one, it will never converge. And also this updation of weight and bias, there is a too much fluctuation. So this convergence of this loss curve will never happen. So if you keep the learning rate for a particular model too high, so it will never converge. And now if you keep it too low, now let me stop this, keep it too low. So it takes a much time. So if we uh, keep the learning rate too low or too high, both are bad scenario. So we need to find somewhere in the between. Let me first reset it. Yes, we can. And this is this blue line, this is actually a dot, the loss distance, this is the dots, and the gap is the distance between the, this is the perfect y-intercept line that we want, that perfectly captures all the data points. Okay, that's all. And the next video maybe I can share more once I complete that program of training that uh, model based on one features and see how it goes. Okay, thank you.